Alright, hello Mr. Luong. This is FRQ number 4, part 8. We're asked to draw a free body diagram showing all the forces acting on the car. And also an arrow indicating the direction of any acceleration. So, let me just draw the system real quick. Alright, so there's a car right here. There's a car. And this car has the forces Fg acting upon it. The force Fg pulling it towards the Earth's surface, so downwards, and Fn parallel to the surface which the car is touching, so Fn right here. These are the only two forces. And for acceleration, there's only centripetal acceleration pointing inwards. You see? Because it is moving in a circle, therefore there needs to be an acceleration centripetal. But additionally, Fn of x is Fn is composed of the two components, Fnx and Fny. And the only force in the vertical x direction, or in the horizontal x axis, is Fn of x. So therefore, since there is no other force in the x axis, there's no force to act against it. Therefore, there must be an acceleration towards the middle, right? And the reason why there's no vertical acceleration is because it states that the car is driving horizontally. So therefore, Fn is counteracting Fg, or Fny is counteracting Fg. And for part B, we're asked to derive an expression of the normal force acting upon the car, given the quantities. So what we need to do first is use some formulas. F of n of x is equal to Fc, and F of n of y is given by mg. And the reason for this... Oh, do you need something?
No, I was looking for somebody.
Alright. Oh my god. Alright, so, and F of n of y is equal to mass times gravity. And the reason why we use these two is because F of n is given by the formula square root of f n y, or x, I guess, it doesn't matter which order, squared plus f n of y squared. And this is because f of n right here, as you can see, the block, right, f of n is given by the components f of n of x and f of n of y, and that makes a triangle, and it's a right triangle specifically, and therefore we can just use Pythagorean theorem. F of n squared plus, or c squared is equal to b squared plus a squared, where c is f of n, a and b are f of n of x and f of n of y. So f of n of x is equal to fc. Well, we know what f of n of x is fc, and fc is given by mass times velocity squared over r. But we can't use r here because it tells us to use theta, and there's no inclusion of r. So how do we find r? Well, the data given is only this one. So what should we do? Well, we can think of this. We can solve this just by using some trigonometry. This is specifically to understand what is happening with theta. Because, alright, so theta right here, well, that's just theta, right? That's a variable. Well, we know here this is 90. This is 90. And this is equal to, because a triangle is made up of 180, that, let's just do a question mark for that. 90 plus question mark is equal to theta. And if we, question mark plus theta. And we can just isolate for question mark, which gives us 90 minus theta, right? So let me replace that with 90 minus theta. So what we know about this is that this is also 90, right? Because this is 90 degrees if you look at it like that. Like this is a straight line, 90 degrees. So if this is 90 and this is 90 minus theta, and we know that a line and the angle of a line is 180 degrees, right? So we can just do the same thing. 180 is equal to 90 plus 90 minus theta plus something right here, right? And to solve this, we can just isolate 90 minus 180, so it becomes theta is equal to question mark. So we got this angle right here, theta. Angle is just theta, right? So therefore, we have the theta that we need to find r, because the r that we're trying to find in this scenario is, where is it? R. Yeah, because we need to find r, right? And r is this distance, right? And to find that, we can just do h right here, or h of, let me check one more time. All right, yeah, because we're just trying to find this h and this r. Oh, I don't even have to do all that. But anyways, yeah. All right. So if we were given this, then we could. Okay, that was stupid. All right, I'll probably get rid of that. So, anyways, h and r. To find r, we have the value. We are allowed to use a variable h, and what we know about this with using these values is that tangent is given by y or x over y, right? And tan theta is given by x over y, right? And here, x is r, and h is y, right? So we have h tan theta is equal to r. Oh, that should be lowercase. These should be lowercases, right? So we got the value for r. So we can just plug that back in right here. So we got fn of x is equal to mv squared over h tan theta. And for fn of y, this is also very simple, because fn of y, oh, it should have been fn of y is equal to fg, right? Because those are the two only vertical forces and components, and we know that the system is not moving vertically at all, so it's in a standstill. So these two forces are acting against each other to make a zero, therefore they're equal to each other, and we just found Fn of y is equal to mass times gravity. So we just plug that into this function, and we get Fn is equal to square root of mv squared over h tan theta squared plus mg squared, or yeah, just mg squared. These should be lowercase. I don't know why I put power. Wait, does it say m is? Oh, they tell us to use big M. My bad. So these, it should be capital M, capital M. This should be capital M. Right, and that is our formula for part B. Alright, for part C, we're asked to derive an expression for the centripetal force, Fc. Well, we already found Fc, right? Fc is just Fn of x. And Fc is just equal to mv squared over r. Right? Wrong one. And v squared over r. And we found that r was just h tan theta. So, all we need to do here, we're done. That's literally just what we needed to find. We already found it earlier, and we just bring it back here. Alright, so let's go on to part D, which asks us to find the derive an expression for v. So we're trying to find velocity here. So what we know about v is that v is given in the formula right here, Fc, right? So Fc, which is equal to Fn of x, is given by mv squared over r. So, well, r is tan theta, right? So we'll just already do that real quick. Just like, Actually, no, that's wrong. Because we should go step by step. And Fn of x is given by Fn cosine theta, right? Because if we go back up here, theta is here, and Fn of cosine is just r. Or Fn, this is Fn, and this is Fnx, that's the x-axis. X-axis, what is it called? Component, x-axis component. is the y-axis component, and Fn, right? So this did come in useful, but right. So f of n is equal to f of nx is equal to fn cosine theta. And what we know about fn is that fn of y is given by mg, right? We already stated this earlier. Or fn, let's do this. F of g, and f of n of y is equal to mass times gravity. We already stated this earlier, right? So f of n of y is just f of n cosine sine theta. So look up here, it's just a sine, right? Sine is given by y, or yeah, fn is cosine theta is equal to opposite fn y over hypotenuse, which is fn, and then shoot, and you just multiply it over here. So fn sine theta is equal to fn y. No, my gosh, I'm so dumb. Sorry. Let me say that again. F of n is equal to fn of y. Right? Because it's opposite over hypotenuse. No, I am so stupid. I am so sorry, Mr. Long. I was correct the first time. It's opposite over hypotenuse, fn, and fn of sine theta is equal to fny. So, yeah, that's what we got here, right? That's what we got here. F of n of y is equal to fn sine theta, which is equal to mass times gravity. So we just want to isolate for fn, which is m times g divided by sine theta. And we can just plug this back in here, and this gives us mv squared over r, and we'll solve for r. We already solved for r, right? We know it's h tan theta is equal to mass times gravity over sine theta times cosine theta. And what we know about sine theta times cosine theta is that is cotangent, right? So we'll just do times cotangent theta is equal to yeah, right? And what we know about this is easy to think about like this. Cotangent is equal to 1 over tan theta, right? So we'll just write tan theta here. And since we have mv squared h tan on here, what we can do is cancel out the tan thetas and also the m's. So what we're left with is v squared is equal to g times h. And we just have to square root both sides, and we get the velocity is equal to square root of g times h. And that's our formula for velocity. And that's it.